Hello, welcome back. This is Mike at Gamefromscratch, and today we're going to continue looking at 2D game programming in Unreal Engine. Today we're specifically going to be looking at sprites and flipbooks. Now, granted, we covered sprites a little bit already, but we're going to go into a little bit more detail. Obviously, for a 2D game, sprites are going to be incredibly important. Basically, the sprite is the foundation of a 2D game. If it's visible on screen, most likely it is a sprite. On the other hand, a flipbook is Unreal's version of, I guess we'll call it a sprite animation. The terminology comes, remember back in the old days when you used to draw little cartoons in the top corner of a book and you flip through it and it caused an animation? Essentially that's a flipbook, and all you're really doing is you're rapidly flipping through sprites to create the illusion of an animation, and thus the name flipbook. Again, we've covered a lot of this, but we're gonna do it again. So first off, we're actually going to need some sprites to work with, and I'm going to show you the entire process in this video. I'm going to do it quickly because I don't want to get too off topic, but I am going to be using Blender to generate our sprites, so you can see everything as it goes. First off, I'm going to use an existing model I already have. I believe it's an FBX format. Nope. All right, let me try that again. It's in DAE format. Yeah, here we go. All right, there she is. This is our character, animated walking character. Let me just show you some animation. There you go. Walks on the spot. And we're going to take this. First off, we're going to start off. We're just going to grab a single frame of animation. And we're going to start with just a single sprite, so you can see it from there. We're going to export this guy out as PNG to start. Hopefully I'll get an error here. There's something very important I want to cover here. I have found again and again and again and again that Unreal Engine pukes on PNG files. Sometimes it works, sometimes the background is completely garbled. So I'm going to try and stay consistent. Hopefully it will generate a PNG file that it hates. Ultimately the answer is you just export it into, I use paint.net or GIMP or Photoshop or whatever. Just export it into a photo editor that supports it. Export it to a Targa and bring it back in, and it will work just fine. But hopefully we'll actually generate that bug so you can see it. Quick topic there. A number of file formats are actually supported by Unreal Engine. They are BMP, Float, I have no idea what that is, PCX, which is an ancient fixed palette format from like the 80s, the PNG format, PSD, which is Photoshop's native format, which by the way are huge, TGA or Targa, JPEG, and DDS and HDR, but the last two are not really applicable to 2D game programming. So the reality is, in that list, the ones you're probably going to use most of are either going to be PNG or TGA. And the reason I mention this is because of something called the alpha channel. Now, when a graphics format is encoded, there's a number of different pieces of information that goes in there. There's different ways that they do it. There's lossy and lossless. Some are just straight dumps of the information, like a BMP. A BMP is a very large file because there's very little encryption or, compression going on in there. On the other hand, you've got fixed palette formats like PCX. Again, a bit of a relic. I'm not really sure why it's supported. But then you've got ones that actually support transparency. Those are the Targa, or the TGA, and PNG. And by transparency, I mean that you can have a see-through background. And that's critical, especially when dealing with Unreal, because it's going to use the alpha channel. The alpha channel is what encodes transparency, by the way. We'll see that in a second. But it uses the alpha channel to do a lot of automatic edge detection and some work for you. So having a good alpha channel is important. The JPEG format, the BMP format, PCX format, all don't support alpha. Now, the PSD format does. It supports probably the most of everything, but again, it's Photoshop's native, and they're huge. So generally, you won't want to use that for 2D game sprites. So my general preference is to use PNG. I find it's a nice compromise between size and compression and graphic artifacts. It creates a nice small file with very few artifacts. However, like I said, Unreal occasionally has issues with it, and hopefully we'll run into that because it's nice when you can actually see them. So now we're just going to go ahead and we're going to create a sprite. Let me just set my camera up here. Make sure we're set to automatically lock to camera. There we go. So just got to pose our sprite quickly so that we've got nicely rendered. Now keep in mind again that Unreal prefers power of two sizes. So what we're going to do is go over here and we're going to set our default sprite to 100% render. And we're going to go say 64 pixels wide, and 128 pixels tall, like so. So now we're properly gated, like here in our camera. Now we're just gonna get her more centered. We want a side view about like that. There we go. All right, that's roughly centered. Make sure that the entire animation fits. Yeah, that'll work. Perfect. Now all we have left to do is add a little bit of lighting. Why does that side look so much better? Our lighting is on that side. Okay, so first thing we're going to do is grab that light. And we'll move it this way. There, that should make our render look a little bit better. Snap back to our camera. Ah, perfect. Okay, so we're going to go ahead and we're going to render just a single frame of this so we have one sprite to work with. We're going to make 64, 128, and 100%. Now, if you're using Blender and you want transparency, a very important thing to be aware of here is come down to shading and alpha for alpha channel. You want to go ahead and set this to transparent, like that. Otherwise, you'll get the sky color, which by default I believe is just gray. But you don't really want that. You want to have a transparent channel instead. So we're going to go ahead, we're going to render this out. It's just a matter of clicking the render button. There. So now we have a sprite to work with. Let me just go and... where's my sprite? Where does it turn to? Temp. Try that again. You bugger. Alright, here, I'll just save that image. Save as image. Alright. We'll just call that sprite PNG. Okay. So now I go here. You shall see we have off screen. Sorry. Here, let me get that on view. We have a sprite. And believe it or not, there is an alpha channel encoded. We'll see that when we bring it into the editor over in Unreal. Speaking of which, let's fire up Unreal. What you see here, this is the Hello World project from our last example. You don't really need to use it. You can. It's got a camera set up nicely, so I'm just going to continue using it. You can do whatever you want. Just remember, you might have to go through the previous tutorial to figure out how to set up our camera right. But adding a sprite, remember, super simple. You just drop it into here. Now, I've created a folder called Sprites that I can bring it in using. So I'll just go ahead, you just grab your file, and you drop it in. Ah, perfect. See? It's garbage. So first off, if I go ahead and I edit this guy, like so, you'll bring up the Sprite Editor. Very key. There's a lot of things you can set here, and we'll get back to that in a little bit of detail. But you noticed how the background here is junk. And I don't know what's going on here, but Unreal is doing this again and again and again with PNG files. PNG files created from different paint programs, created from Blender, created from Max or Maya. Doesn't matter the source. It just sometimes screws up with PNG, and you see it's mangling the background here. I don't know why it's doing this. I'm glad it did it, so we can see it right away. So we'll just go ahead. We'll delete that sprite out for now. Just hit the delete key with it highlighted, and the sprite is gone. So now we have this catch, and we just want to go ahead. So sprite.png, we'll open it up in, this is paint.net, a free editor. Now you see this checkerboard background? That's showing the transparency that's encoded, which is nice. And we're just going to come in here and do a save as, and we'll turn that instead into a targa file. Again, I have no idea why Unreal is having this issue with PNG files, but it is. I would just call it a bug. I assume it's a bug. I'm assuming it'll be fixed at some point. Just be aware of it. So I'm glad you saw that because it happens again and again and again. So now that we've got the target encoded, let's go ahead and we'll just drop it in. And there is our sprite. Zoomed in a lot so it looks like garbage, but there it is zoomed out a bit. And this is your sprite editor. There's a lot of context-sensitive editors hidden away in Unreal, and this one is obviously for editing in details of a sprite. Just a quick thing to notice, though, and if you didn't want to do it this way, if you did not want for some reason to drag and drop, you could also create the sprite going this way. New, import to, and then select your file. Same end result, just want you to be aware that there's the two different options. Now, there's a number of things you can set over here. And generally, you're not going to do too much with it. Like you can change the brightness, the saturation, the vibrance, the hue, the transparency level, so the alpha, min and max. You can tweak the compression and all of that stuff. Now, the kicker here, and this one is important to understand when you're working with a 2D game, and your results are going to look a little, let's just say garbagey when you import it because of this. this MIP generation setting. Now, a mipmap is an old-fashioned optimization trick. It's Latin. Let me see. MIP stands for multum in parvo, which I probably mangled how that actually is said, but that's what a MIP is, and that means much in little. It's an optimization trick, and the whole idea is, and you've experienced MIP maps hundreds of times if you've played any games, you know what we traditionally call texture popping, where as you're like seeing something in the horizon, and then as you get close, you see it pops more detail, more detail, more detail as you're coming in, where textures are being swapped in and out. That's generally a mipmap in action. And what it is, a mipmap is multiple resolutions of the same image being created. So when you're very close to something, you may need a 1024 by 1024 or even bigger rendition of it. But when you're very, 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 very far away, you might be able to get away with like a 64 by 64 pixel version of it. And a mipmap automatically swaps these as it comes. So things that are far in the distance, therefore, use up less texture memory, less processing, etc., for being further away. And then as you're swapping in, it's putting in the higher resolution versions. Now the thing is, in a 2D game, there is no depth. There is no concept of further away. We do not want mipmaps. Now, keep in mind, Unreal is a 3D engine doing 2D. So it's still doing things 3D-ish. So when you bring in a sprite, it's automatically generating mipmaps for them. But again, there's no depth. We're never going to go farther in or farther out. So having multiple versions doesn't work. And in fact, it actually makes it look kind of crappy because you're not getting the native one that you wanted necessarily. So that's what this mip gen setting is. So when you come in, just go in here and say, no mipmaps. And that will make everything look better. You're going to want to do this for every single texture you import, to be honest. And that's about it. So when you're done, just click Save and Done. Now, one of the things to remember in the past is you can have textures, which are graphic files and sprites, but you can't instance a texture ever. Now, a sprite, no problem. Here, let's go ahead and let's create a sprite. And what the hell did you just do? All right, come on. Alright, I screwed something up. Alright, why are you creating a material? 1 second, something's gone wrong. Oh, jeez, I'm running into my own stupidity. Sorry, I'm skipping a step completely. At the same time, I'm trying to explain exactly what I'm doing wrong. Alright, there's two things. There are textures and sprites. Textures are the graphics that go on. Basically, a sprite is an instance of a texture for the most part, or part of a texture, or a portion of a texture, or the entire texture. But a texture itself is the raw image. So basically, you have an end-to-one relationship. You can have multiple sprites, but you have one texture ultimately. And what I was trying to do was instance a texture. You cannot instance a texture. They are not usable in-game. I was being an idiot. So let me start over again. So here I am in my textures folder now. Go ahead and bring our sprite in, like so. Okay, now we'll click it, we'll come in, and we'll set its mip mapping to off, like so, and save. Sorry about the distraction here. Okay, so now we've got it. Don't try and drag it on the scene. You cannot do that. First, you need to turn it into a sprite. Just right-click it and create the sprite. And we'll just call the sprite my sprite. Like so. Now let's take our sprite, drag it over to our sprites folder. Of course, you don't have to do this. This is a completely optional organizational thing. But now that we've done that, we can instance our sprite, like so. So now our sprite is in the game. Now, a very key thing to understand here, though, is order. Now, I covered a little bit this past. It's worth mentioning it again. There is no depth in a 2D game for the most part. However, ordering that things appear is important. So right now we've got our sprite selected, and you'll see that so remember, Z, the blue axis is up and down, whereas Y, the green axis, you can't see here, but green, that's into the screen. If I switch over to perspective, you'll be able to see that a little bit clearer. So there's the green axis right there, in and out of the screen. Okay, now the y-axis is important for determining what's on top of what. So here we go, we've got our background sprite, and it has a location of 0. And then we have our foreground sprite, and it has a location of 0. Now it's going to be a little random what's going to turn up being on top of each other there. I think it's on construction order, but I'm not positive there. But if I took this for a second and turned it back into, say, -2, and then we switch back to our front view, our sprite is now obscured. If I go ahead and play, we won't see it. All right, I'll stop that, and I'll come back here, and I'll set it to +2, so it's in front of our background image, and we play it, you will see it. Okay, so that y-axis is still important for determining order that things are on top of each other. On top of that, you'll also want things to be at the same level if they're going to interact with each other using physics. We'll touch on that later, so don't worry about that too much, but do keep in mind the y-axis does have some importance here. So that's bringing a sprite in. Let me recap because I was kind of stupid in my initial explanation. You start by creating your texture. Your texture can be brought in by just drag and drop. Again, PNG files seem to be a little buggy for some reason for TGA. Bring in with a better background rendering for some reason I don't know yet. But then you just go ahead, right-click it, and create a sprite from it. This in turn creates this guy. Now, here I used right-click, create sprite, but you can also do it this way. Here, let's get rid of our sprite completely. Yeah, all right, now it's gone. We could also have gone new, and then it's a miscellaneous sprite. And we shall call it my sprite. Now, this is making it from scratch, so you have a little bit more work to do. Now, you look over here, you will see source sprite. And we just go ahead and we can go here, select our sprite, and click this source sprite. Hey, why are you doing that? Let's go back to sprite. We'll double click it. We'll bring up the editor here. Source should be. So go to our texture, we select our sprite, and we set it as the active sprite, like so. So we're into a new guy here. This is actually, we saw the material editor earlier. This is a sprite editor. Same concept, different stuff. First off, as you can see, here you can define where your texture comes from. And then also the default material. We'll touch on that in a sec. You know what? I'll touch on that now. No, I'll touch on that in a second. So this is where you actually come and you edit your sprites. Again, remember I told you a little bit earlier, a sprite can be some of or all of a texture. It doesn't make a lot of sense at first when you're dealing with just one sprite. When you're dealing with multiple sprites, it suddenly makes sense. When you're dealing with a sprite sheet, and then a sprite could just be a portion of that sprite sheet. Well, that is done using these guys up here. First off is your edit, your source region. So as you can see, our sprite right now is using the entirety of the volume it came from. Now we could go ahead and just make the sprite use, let me see, drag handlers to it. Oh yeah. Let's go. Come on, handlers. Yeah, this is not as intuitive. That's it. Double click to start. I don't know why. So let's double click that guy. And we drag that up. So now you'll see, if you look at the preview over here, our sprite is only using that portion now. So if we click back to, let's do a save, and we exit out of the sprite editor and go to our sprite and we make an instance of it, you'll now see that we're only using that bit. Alright, so now we go on back to the sprite editor, just double click it, bring us back into the editor, go back to the source region. So once again, for some reason, double left click to start, and then we'll just drag it so it uses the entirety of the texture instead, like so. Now it's back to normal. We'll click save, and we'll shut this editor down, and then now you see we're back to using the entire sprite. This will make more sense when you're dealing with multiple sprites. Now next up, I'm not going to touch on them too much, but there's collision and render geometry. Collision that's the collision detection mask. Alright, so this is important on the level that when you collide with other things, this is the bounding box used to determine. Now there are options, we will cover it when we get back here, but you can have it automatically figure out, etc. But you'll notice that here, go back to the view, right, source region, our image is using this much space, right? When we go to our collision, it automatically snapped down to just the visible pixels. Well, how did it do this? This is where your alpha comes in important. Is basically Unreal looked at the alpha of your image, made the smallest box around it, and has automatically created a collision volume that fits just the visible pixels of your sprite. Very handy stuff. Finally, you can edit the render geometry. This isn't something you're going to be doing very often, but ultimately a sprite is a 2D texture plastered onto a quad. So as you can see up here, there's one polygon with 4 vertices, and this is it. Now, sometimes you can have a non-standard, non-rectangle looking thing, and for some reason a different bounding shape would work better for you. You can add polygons, shape it correctly. I don't see a lot of win on this. I don't know why you would do this very often, but you do have the option. You can change your quad into just whatever shape you want by basically adding polygons up here and moving them around. So render geometry and collisions are 2 things we'll get back to later on. And source region is something that will make more sense when we start dealing with multiple sprites in the same volume. All right, so let's flip on back to view. So this is your sprite editor. For the most part, all you will come in here for is to define these things, or if you're manually creating your sprite like I just did, you set your sprite here. And then there's this default material. And as it stands, default material is everything in Unreal has a material attached to it. Behind the scenes, it's ultimately a shader, and there is a shader for everything done. Now let me go and show you quickly. What was the fastest? Oh yeah, over here. So go over to collections, and you'll find out that there's a couple built in. View options, and we want to show as plugin content. So the show plugin content, click that there. You'll see Paper 2D, which is our 2D plugin thing here. And there's 2 important shaders here, or materials as they're called. Default lit sprite and default sprite. Only difference is, does one of them have support for lighting and one of them does not. So if you're using dynamic lighting in your scene, you'll use a default lit sprite. Otherwise, you will just use a default sprite. Now, if I click one of these, double click it, you'll actually see, it'll bring up the material editor. Now, this is going to be very scary. If you've never done any shader programming in your life, you're going to look at this and go, ah. Now, the nice thing is, between those 2 shaders that are just provided for you, unless you're doing some special effects or something a little bit beyond the norm, you're never going to have to come in here. You can get by with the default sprite material, or if you're using lighting, the default lit sprite material. That's enough for you. However, I just wanted to show you this. And once again, there's another editor hidden behind the scenes. This one is the material editor, and this is pretty much creating a shader graph. Kind of can't really explain this too much if you don't understand the render pipeline, but basically this is saying for each texture coordinate, or so each location inside of the texture, multiply it to get the emissive color, and then let's see, how else does this work? Opacity. Yeah, so basically you're take the color value out to the emissive and the alpha value out for the opacity. And this is it's okay. I can't explain this in a short period of time, so I won't really bother. Sorry about that mumbling through it. But essentially what this does is it goes through every single texture, every single pixel in your texture, and kind of sets the output as emissive and opacity. Emissive you can basically think of as color. And that's kind of it. So again, if you're not working with materials, if you're not doing anything weird with shaders, you'll never come in here. But if you are doing shader programming, this is essentially where you do it. You can also do shader programming in Unreal, but that's way beyond the scope of what we're dealing with. All right, so get out of there. So that is the material. And again, what you generally would come down to is you either would set it to default material and then click, or default lit material and then click. So now as you see, it's being affected by the lighting of the scene. So I go up here and I switch that to lit, you'll see the results. Now obviously the lighting isn't set up in any way we want, so we're not getting probably how we want. So we'll just go ahead and set that back to unlit, like so. And that's it. That's the basics of dealing with sprites. It's quite simple for the most part. You bring in your texture, which is your source for your sprite. You create a sprite from it, and then you're off to the races. The only other value that's of kind of some interest is this guy right here. Now, excuse me. This pixels per unit is a mapping. Oh, there you go. Yeah. It's the mapping between Unreal units and pixel units. Because as of by default, Unreal works, I believe, in millimeters. So 1 pixel at this point, or sorry, 1 millimeter is 2.56 pixels. You don't really need to change this. It's just when you've got that, this value here is determining how big it is within this world, with how big the snapping is for each of these. So I think we're set to 10 units per cube, and then so 1, 2, 3, 4, 5. Our guy is 128 up times 2.56. It's just, again, it's literally just a mapping between the millimeter units and pixel units. And if you want it to be bigger or smaller, whatever, that is done here. But as long as you're consistent across all your sprites, it really doesn't matter. You can do it however you want. And then another guy, and we'll cover this later on when we actually deal with physics, but you can set to using 3D or 2D physics. I believe 2D is kind of buggy at this point. Some people mostly use 3D. But that is another thing that can be set here. All right, so I will save that and exit out. And now we will move on to Flipbooks. A flipbook is the animation system for 2D sprites. It literally is just a collection of sprites shown one after the other, a sequence of them. And generally, you start with something called a sprite sheet. And let's show that entire process. Remember back here in Blender, here we are with our scene. It's set up for, let me just see how many I've got. Alright, that looked like about 30 frames of animation going on here. So just go up here and we shall start there. We will end at 30. We will go 1 frame at a time and render. All right, so now we're going here and it's generating each of our frames like so. Now, if you really want to see this, here it is in frame by frame. Right? So that is each frame of your animation as a single image file. Now the reality is you generally don't work like this. You want to actually probably merge all these guys together into a single file. And this kind of is a catch-22 with Unreal, because Unreal has done something really stupid and really clever at the same time. So let me just go ahead, and we're going to use a tool here called TexturePacker. There's a free version, TexturePacker Essential, available, and that's what we're going to go ahead and use. We'll create a paper 2D project, but it doesn't really matter which one you pick. We just want it to generate the graphic file. This is not of use to us right now. So all you do is you just take your images. First one to the, oops, he's not one of them. All right, so all your images like so, and you drag them in. Okay, so there are some limitations on the free version. First off, that has to be 0. We want to set this to power of 2, like so, and we want to be basic. So they just show up as a grid. And we also want to make them the same size. Okay, so very simple. We're just merging all of this into a single image, like so. And let's go. We need to name our texture file, so we will call this Sprite Sheet. And we shall name this doesn't matter, won't use anyways. And then we just publish. All right, so it's done and out. So now if we come back here, we shall see our sprite sheet, like so, single image, all of our frames of animation in it. And now we're going to run into more Unreal fun, I think, because it is a PNG file we just generated. So let's go back to our textures, like so, and just drag that guy in. And it's garbaged. Let's see if anything can, maybe if I set Mipmaps off right away. Yeah, I got no idea what's causing this. Again, I'm just going to call it a bug. Let's go ahead and delete that. Force delete. Install. Yes. Now let's see if TexturePacker has image options. I might be able to do it. Yeah, okay. So I'll just go ahead here and save it to a TGA. Alright, so we'll create a TGA instead. Alright, the basic version can only do ping. Yay. Alright, one more step here. Just grab our sprite sheet. We'll edit it. we shall save it as spritesheet.targa, like so, like so. And then back over here, grab our new targa and drag it in. All right, so that now looks right. Now, quick thing to show you here. So first thing, I'll turn off our mipmaps again. No mipmaps. Come on, mouse. So here you're seeing the channels that are enabled. We're seeing the red, green, and blue being rendered in this preview. And let me just go ahead and turn the background into a checkered. Okay, so it's set that right. Now let's turn off all of these channels. So now we've got, well, we're showing no color. Here is your alpha channel. There you go. So that is what is determining transparency. Pretty much anything that is black is 100% transparent. And anything white is not. So what it's using, when it was determining the bounding volume, the amount of space, the algorithm was looking at this alpha channel here and determining the smallest bounding space around that surface. This is why alpha channel is important to it, because it does do these calculations behind the scenes. Also, of course, if you didn't have alpha channel on, you would get a square background in behind your image each time you go, which obviously you don't want. Okay, so that is importing a sprite sheet. I changed to no mipmaps. Everything else is fine. So go ahead, we'll save that and exit out of this editor. All right, so now we have a sprite sheet. We want to go ahead and create our sprite frames. This is both very easy and very difficult for very stupid reasons. First off, I guess we don't even need this guy anymore. Edit. Delete. All right. So here's our image with all of our frames on it. And thanks to that alpha channel, we can now sit here and we can go right-click and extract sprites. Like so. And then boom, it automatically figured out all of the different frames for us and created a sprite for each one. So I can just grab that, move it over to our sprites folder here, do a move, and done. So now we have all of these different frames that can be used now in an animation. I should have probably put them here. Let me just go ahead and make a folder. We'll call that walk. We'll call it walkie. And then I'll just grab everything other than sprite and drag it in. Now, we're also going to see one of the infuriating things about what Unreal just did. And it's using this algorithm to determine the name. And these frames should ideally match these frames. And they don't. Not even close, which is irritating. So here, let me bring this up side by side. So we're going to want to collapse you down. And there's our sprite sheet. And we'll put it to this side. And we'll zoom that in. All right, so ideally, our first frame of animation should be that guy, which it is. And then it should be this guy, which it isn't. Isn't. The order that it's pulling these sprites is nonsensical. I don't get what it is. And then even worse, let me show you something they've done that's really stupid here. Is you've got, let's see. All right, here we go. It automatically names them based off the frames it pulled out. And this is why this is nonsensical again. Because here's sprite nothing, sprite 0, right here. So got the name spritesheet underscore sprite, right? So then the next one you would expect to be sprite 1, which is right somewhere. Now, sprite 0 might actually be sprite 1. Okay, so let's assume that sprite with no name is sprite 1. Now, next one you would expect is 2, which is now down here. And do you see why? It's because for some nonsensical reason, they think that they're using it like an alphabetical sort as opposed to a numeric sort. So, right, you got 10 is your next frame, 11, 12, 13, 14, 15, 16, 17, 18. It's nonsensical. It was a really stupid decision they've made. People have already filed tickets to actually have this process fixed. Hopefully it's something that's going to come soon. But let's take a look at how these are actually being generated. Let's grab our first sprite. And we're back in our sprite editor. All makes sense again. Now this suddenly makes a lot more sense. Because now you see there, our first frame is in fact here. right? So then we have our next guy is Sprite, I think 2. 2 is the second one. And now what we want to do is get it so that 1, 2, 3, 4, etc. on and on. And basically, the most painful way to do it, or the least painful way to do it, is to rename them. This is just a gross process, but it does show you something else that you can use. Let's grab all of our frames of animation like so, and then we shall go into the property matrix. And here you're seeing them all in one grid. So you can edit any of the commonalities. So they all have a source UV, they all have dimensions, they all have the same texture, and they all have, well, an atlas group of none. But you could come in here now and you can see all of your values as one single entity. So you see your first guy is starting at this location, and it has these dimensions. So you can come in now and rename. So what we want to do is go Sprite. I can't rename. Why can't I rename here? Okay. Guess I'm not going to do it that way. Well, that's infuriatingly stupid. Alright, so we'll get by without it for now, as annoying as this is going to be. And let's move to the next step. Now, you're going to have to get over this nonsensical naming convention, because unfortunately, it's what we have to work with. And again, this process hopefully in the future gets fixed, and the extracted sprites are much easier to use. So let's go ahead and we'll just make a flipbook now. I'm going to organize things slightly for that. So let's create a new folder. We shall name it Flipbook, like so. And we'll just go ahead and create a new one. So new animation sprite flipbook. And we shall call it walkie. Okay, so this is a new flipbook. And we'll just come in here and we'll double click it. And it's bringing up the Flipbook editor. Again, there's an editor for everything in Unreal. And this is the Flipbook editor. This is where you pick your sprite frames to be animated, to be part of the animation. So we're making our walkie animation, which is our walk cycle. And you see down here it says, right-click here or drop in sprites to add keyframes. Well, now the key is we come back to our sprites here. And let's just make that way, that way, and bigger that way, and we'll make them a little bit bigger by changing the scale here. All right, and now all we have to do is we take each logical frame of animation, and you just drag it over here and in, and you'll see it automatically starts playing that frame of animation at this frame rate. So let's set this down way lower. We're going to update our frames at 5 frames per second. That means it's going to take 5 seconds to get through. It's going to take 1 second to get through 5 frames of animation. So that is our first frame of animation brought in. So now we want to go to the next one, which is 2. And then we want 3. In theory, I should be able to shift collect 4 through 9. We'll drop them in. And there you're seeing our animation. We've got one bad frame in there. I'm not sure which one. You can track through down here with the timeline. So there. All right, so frame 6 is right, and then for some nonsensical reason, the import for 7 is wrong, and 8 is wrong. So after 6, all right, how did our image go? 1, 2, 3, 4, 5, 6. All right, so that's what it's doing. I bet you it's going here next and going backwards, which would be ludicrous. But 6, so 1, 2, 3, 4, 5, 6, 7 frames of animation. So the next frame is probably that looks right though. Well, it's going to be painful watching me munch through this. So let me just pause. I'll figure it out, and then I will get back to you. I think ultimately what we want is to do uh, 0 through 6 are the first sets of frames, and then 7 is going to be actually the last set coming backwards. So if I still have my image open, which I don't, here, open it up, is the extraction seems to have worked this way. So grab this guy, this guy, this guy, this guy, this guy, this guy, this guy. And then I think what it's done is grabbed this guy, this guy, this guy, this guy, this guy, this guy, and this guy, which again, I don't know why they would ever think to do this, but I'm pretty certain that's what they've actually done. So I've got to figure out if 6 was the last guy here, that's 7. Is that 7? All right, so that's 7 there. 7 is a full walk, so there's 7 there. That's actually what we want. And then 8. Okay, so it's 8 that's wrong. 8 is... Oh yeah, that makes no sense. That's frame 8. Right there. No, that's 8. There. And then where's 9? There's 9 here. So 9 is... there. 8, 9. Oh yeah, I don't get its logic at all here. So let me just figure this out quick. Oh, you know what? The very simple way to do it is to grab your sprite, edit it this way, and then find out where it grabbed it. So 9 is the last guy. 8 is second from. 7 is there. 6 is there. So 6, 7. Okay, that makes no sense at all. 9, 8. Let's find out where 10 went, even though that makes no sense. 10. 11. 12. Okay, this makes no sense. The fastest thing I'm going to actually be able to do is just write them down with pen and paper. So I shall pause. Sorry, I'll be right back. Okay, finished calculating it all. I have no idea the logic here, but basically, this is it. So, corresponding these frames, it has extracted. This guy is nothing, 2, 3, 4, 5, 6, 7, 12, 13, 14, 11, 10, 8, 9, 15, 16, 17, 18, 19, 20, 21. So that row actually kind of makes sense. 24, 25, 23, 22. So there might be a pattern here. I'm not seeing it. I would basically just say Unreal has a lot of work to do on their sprite extraction algorithm, and please change sorting so that 11 does not come after 1 and before 2, because that makes no sense at all. And it kind of, I was thinking about renaming them. I could come back in here and go basically call this guy Sprite 1, but then I'm going to run into the same problem, because then Sprite 11 is going to come next, 12, 13, 14, 15, 16, 17, 18, 19, and then 2, and then 21, 22. It's nonsensical, so there's no sense even renaming it. So I'm just going to go with their nonsensical values for now, and we'll hope that this gets changed in the future. So let's go back to our Flipbook here. And let's just stop that for a second. So you know what? It's just as easy for me to... I'll start over. So let's just delete that guy. Yes to all. Yep. All right, so let's create a new Flipbook. So new animation sprite Flipbook, and we shall once again name it Walkie and edit. And now we want to bring in our frames. Again, here is how I came up with them. And once again, it was just the the kind of painful process of for each sprite, I went into, stop autosaving. I went into each frame like so, and I figured out where it was. So I looked at the name down here. So if I wanted to figure out where frame 10 was, I basically just clicked it twice and went to edit source, and I figured out which offset it is. It's got to be a less painful way than this. There's no way that they're going to leave it with this. This is a very buggy way. All right, so what's going on here? Something's wrong with my computer all of a sudden. Nothing out of the ordinary. All right, leave that running. So go back to our Flipbook editor. Okay, where'd you go? Like so. Let's go back to our sprites over here. And we just want to bring in the frames corresponding to these values over here. So I shall bring them in order. It's that guy. Probably easier to work with a list, to be honest. And let's zoom our view back out to give me more details. All right, so I need sprite 2. It's our second frame. And then 3, 4, 5, 6 should be pretty much in order. 3, 4, 5, 6, 7. There's our next animation. And then we've got 12. Like so. And then 13. Like so. And then 14. I should have shift collected those ones. And then 11, for reasons I can't fathom. And then 10. And then you would think 9, 8, but nope. 10, and then 8. And then 9. And then our last row, at least, is in sequence. So we want 15 through, sequence it to normal people. So 15 through 19, and then we want 20 and 21. Like so. And then 24 and 25. And then 23 and 22. Okay, so hopefully I calculated that all right, and we have a nice walk animation. All right, computer, what are you doing? My computer is not happy with something. Try that again, see if it's... All right, I'm not in real-time mode anymore. There you go. So there's our walk cycle for our character. That was a needless amount of work. Unfortunately, that is just the nature of the auto creation right now, which is very annoying. I think I got one negative. I think one of my frames, I might be wrong in there too. But essentially, that is a character walk cycle created in a flipbook. When we create an actor later on, it will tie it all together. It'll be much handier there. The last thing to really be aware of is these guys. And for individual frames, if you wanted to hold the first frame a little bit longer, you could. So let's do say 10 seconds on the first frame, or 10 frames on the first frame. So you'll see it pauses and then it continues. And then on the last frame, we can do the same thing. It's going to have basically the same effect as if we did 20, to be honest. But so you can hold certain frames for longer and then run. You'll see frame goes, 10-second pause, or 10 frame pause. And on that topic, let's go set this back to 1 frame. So if you've got certain frames that you want to last longer, you can edit them at a level here. I'm going to have to wind this. I've got to have a memory leak or something because my computer is getting slow. Or you can change the overall frame rate here. So we touched on this a little bit earlier on, but basic idea here is this is the amount of time, or the amount of frames that happen in a time frame. So in 1 second, 15 frames of animation will happen. You see we have 25, so that means it's about 1.5 seconds to do our entire walk cycle. We could slow this right down to say 7, and you'll see the walk cycle slows down very significantly. Or we could speed it up to 30, and you'll see, well, it looks like crap, but then it speeds it up significantly. Or we go back to about, say, 13, and it probably looks about right. So that's controlling it on the macro level. That affects all frames, and this affects each individual frame if you wish to. That's about it. So we're not going to really, here, let's save that. close this editor down. We're not really going to use it for anything as of yet. Our flipbook is not really that useful until we have an actor. You could put one in the scene if you really wished. Sure. And there you go. There's an animated character doing nothing. But generally what you do is you have an actor that runs the flipbook. So as you've got to walk, you use walk accordingly. So you'd switch, and you'd have that flipbook as active, or you'd switch other ones. We'll see that shortly. But here you go. You can see our character is now walkable. We've created our flipbook. So let's do a quick relapse or recap of what we just covered. First off, going back to textures, these are your source images used to create sprites. So either portions of, as you saw with our sprite frames, where each frame of animation was part of the same texture. So this texture has multiple sprites in it, whereas this texture has a single sprite in it. Once you imported it, one of the things you probably want to do if working on a 2D game is turn off mipmapping so that they aren't used, because again, there's no depth, there's no detail change in depth on a 2D game, so it's a wasted feature and it can cause rendering artifacts. As we saw earlier, for some reason importing PNG files is problematic. I don't know the answer behind that. I don't know if it's something about the way pings are encoded, if it's a bug in Unreal, or if it's a bug otherwise, but it seems to like TGA files better. So once your file is imported, again, you can double-click anything to bring up the editor accordingly. Mostly you'd use this one to change the mipmapping or your overall display settings on it. Again, you can toggle between alpha channel can be shown on off, so you can see how the transparency works in this guy. You can toggle off each color value. And then you create a sprite editor. Right-click, create sprite. So then you've got your single sprite, like this guy. A sprite, unlike a texture, can now be instanced. You can drag one into the scene, and now you have a sprite. Now, Sprite, again, double-click it, has its own editor. The biggest things that you will use here is you can set your material or your source sprite here. Your material, again, there's two built-ins. There's one for lit scenes and unlit scenes. Which one you want to use is completely up to you, or you can get creative and invent your own. You can, okay, I don't know if you can from here. Yeah, you can edit it from here, bring in the material editor. You can change things around in here, way beyond the scope of what we were going to cover, though, so I'm going to shut down that. But that's essentially shader programming in a cross-platform way. You can also do a macro level change here. You can change the sprite, give it an overall tint, so we'll give it a redness, and now we have a reddish sprite. Not going to generally use that very often. The physics stuff we'll cover on later on. So the only other real thing in the editor that's of importance is this guy right here. And this is your mapping between the millimeter units that Unreal uses and the pixel units that your sprite uses. So basically it's a way of saying a sprite is this many millimeters, or 1 millimeter is 2.56 pixels. It's essentially what you're saying here. You can change that around. But as long as you stay consistent between all your guys, that should be fine as it is. So once you've got your sprites done, you can also create animation using a sprite sheet. So as again, we brought in one single animation here with multiple frames, and then we used the right-click command and said extract sprites. This in turn generated a bunch of individual frames like this that we can now put together to make our single flipbook animation for them. As you saw, the naming convention that it extracts them from is nonsensical and stupid. And again, alphabetical sorting is useless because it's using this method where 19 comes before 2, which makes even renaming things frustrating as hell. And your ordering, I don't know. If you can make sense of this, feel free. Hopefully this is something that gets patched. Again, this is all beta stuff, so hopefully they change this all out soon. But once you've got your frames here, you can just create a flipbook, and then you just bring them in by, let's open our flipbook editor back up. You just drag your frames across and down here to make your sequence as you go. You can modify your frame rate of the entire thing, or you can modify how long each particular frame of animation lasts. And that's kind of it. We'll shut that down, and that is sprites and flipbooks in Blender. Sorry we had a couple more hiccups than I generally like to see, and for some reason my computer is slowing to a crawl. So sorry about the artifacts we had there, but hopefully that all made sense. See you next time. Thank you very much.